Hello, my name is Amy Lee, and today I'm going to show you a pretty cool demo of how to read in a voltage using the internal ADC12 bit inside a MSP430F5529. We're going to convert that voltage to a code and send that code serially through UART and use Labview to display that code of voltage versus time. So let's get started. So I want to show you the block diagram and my MSP430F5529 launch pad. This is what the launch pad looks like. You want the following jumpers to be connected, which is the RxD and the TXD. That's going to be for the UART. I'm connecting the voltage to port 6.0 and also to ground. And also don't forget to connect to your launch pad to your computer using this USB connector. This is the block diagram of my system. Basically, I'm using a battery of 3.3 volts and an R pot from 0 ohm to 23 kilo ohm. I'm going to vary this resistance to vary the voltage. There's a bottom resistor of 10 kilo ohm, and if you use your voltage divider, you can figure out what input voltage I am getting. If I have 23 kilo ohm R pot, the VN is 1 volt. If the R pot is 0 ohm, the VN is about 3.3 volt. So I'm varying a voltage between 1 volt and 3.3 volts. Inside the MSP430F5529 on the launch pad, there's an internal 12-bit ADC, and I'm connecting that to port 6.0. The output code is going to be displayed in this register called ADC12 MEM0. Note that if I'm using port 6.1, then the register will be MEM1, etc. So the output code is a simple equation of Vn times 2 to the 12 divided by Vref. If I'm using a maximum R pot, then Vn I'm getting is approximately 1.017. 12 because it's a 12-bit ADC. And then I'm going to show you how to configure the ADC to use the internal 3.3 volt for the reference. So output code I should get is about 1262. That's in decimal. I'm going to send that code serially through UART, and then I will have Labview on my computer to show that code in terms of voltage versus time. So the development environment I'm using is the IAR embedded workbench. You can use others as well. But once you download this tool, I'm going to show you the C code that you can write or copy to configure your MSP430. So click on project, and we're going to create new project. Choose the externally built executable and give it a name. And once you have that, you can right click on the project name and click choose option. This is where you can configure the MSP430 you are using, and I am using the MSP430F5529. Under the debugger, please make sure your driver is a FET debugger, or else it will not work. On the FET debugger, you're going to choose the COM that you are using. If you want to figure out which COM port to select, basically open up your device manager and it will show right now I'm using COM 13 for my debug interface. Please also note that COM 12 will be for the UART that I will code in my Labview later on as well. So I'm going to select COM 13 and click on OK. Next, I'm going to add the pre-existing C code file by right-clicking on the project, add file, and this is a pre-existing code file that I will slowly step through to show you how to configure the ADC and the UART. There is a MSP430F5529 file that you can open, and this basically will give you all the parameter name and give you some explanation of the register that you will use to configure your ADC and your UART. So to start building the project, I'm going to go under project and rebuild all. This will check if there's any errors or warning. If there's none, you can click on Control D or this download and debug button, which will now download your code to the MSP430. So I'm going to slowly step through each line of code, starting with the main function. But the very top of this is the include MSP430 file, and then this array, volt array of integer that I'm going to explain later on. This is where I store my code and then convert that to ASCII. So to step through each line of code, I can either go to F10 or F11, or if you want to run the code continuously, that will be F5. So let's step through each line of code. Once I do that, I also want to probe the register to see which register I have configured. You can go to View, Register, and choose Register 1. Right now, I'm going to configure the ADC first. So right-click on CPU Register View Group and choose the ADC12. Or actually, you can also probe the port. Okay. So let's step through the main function first. F10, this is a line to stop the watchdog timer. I've created integer in value. And then the next function is called setADC. I'm going to press F11 to step through that function. So these next 6 lines of code will enable the ADC. I do recommend opening up the ADC, the MSP430F5529 datasheet, which you can look on ti.com. Once you open the datasheet, section 6.9.16 will link you to another datasheet just dedicated for the internal ADC12. So if you click on this link, opens up this datasheet for the ADC. Please, I do recommend, my code is only specific for a setting. If you want your own setting, you can read this ADC12, bit ADC12 datasheet. I like to look at the register. It will give you a detailed description of the bits inside each register. So please go to that as well to figure out how to configure the ADC or the UART that is separate from what I'm doing here. So first I'm choosing the port 6.0, which is the P6 select. I will set to 1. As you can see right now it's nothing, but if I press F10, now the P6 cell 1 is going to be set. I'm going to go back to my ADC12 and I'm stepping through each line of code. You can see how each register has been programmed. So this is another way for you to debug. Right now I'm just turning on the ADC12. I'm going to extend some sampling time, use the sampling timer, repeat a sequence. This line of code selects the reference as a 3.3 volt, and then I'm going to enable the conversion. F10 will step me back out of that set ADC function back into the main function. The next function is an initialize UART. So F11, now I'm going to set up the UART port, reset the state machine. I could also probe the UART1 to see which register I program as well. This line of code selects the clock, which is 32.7 kilohertz, and the baud rate of 9600 hertz. This is very important to be able to communicate effectively with my Labview via UART. So to make sure I'm setting the appropriate baud rate. Now this line of code will initialize the state machine, and then that's the end of that function. Now I'm in this while loop. I'm going to start the ADC conversion and enable the ADC. So my resistor RPOT is approximately maximized up, and I'm getting a voltage about 1 volt. So let's set it to about 1 volt. Okay, about 1 volt in connected to port 6.0. So if I go back to that step, I can also view the watch to view what code I'm getting. So that code is here. If you want to rerun that, you can right click on the previous step, press F10. So yeah, so right now that 1 volt is approximately has a decimal code of 1260. I just changed our part a little bit, so you can see that in value is 1260. I'm going to pass the in value to another function called ADC value. And as I'm stepping through, the code will change because of noise, but it's approximately going to be around 1260. I'm going to press F11 to go in that function. Basically, that function will now have this volt array that I defined earlier in the beginning. I'm massaging that code to ASCII by adding 48 to it. first with MSB bit, and then bit number 2, bit number 1, and bit number 0, and then the end of line. So you can see this is ASCII that represents my my code from output of the ADC. So step out of that function and into the send serial function. So let's see the send serial function again. F11 will go to that function. So that function then will transfer that to the UART buffer. The UART register. So I'm going to start with 1, 2. I've stepped through this at least once, so now that code has changed a little bit because of noise, but I'm reading approximately about 1 volt. So I got 1295, and then I'm going to send the end of line. So once I'm out of the function, I'm going to go back to this while loop. You basically, I can run my code continuously, and it's going to be running in this while loop continuously. I'm going to press F5. So next, I'm going to open up my Labview, and I built a pretty nice plot window in the front panel. Control T will take me to the block diagram. It's a pretty simple block diagram. If you have used Labview before, each block represents something. There's a shortcut quick drop that I like to use, which is Control Spacebar. Opens up the quick drop. You can write the name to some of these blocks and open up the block. You can also go to View, Functions Palette, which is where all your programming will be located. So if you click on the block and go to Control H, that's the help. It will give you the ins and outs of the port, and detail help will give you more information on how that block works. Right now I am giving a VISO resource name, which is the COM12, and I am selecting the baud rate of 9600, data bit of 8, no parity. I'm sending that to the configured serial port, writing it through and reading it through Visa, and then scanning that string. Remember how I have a voltage code of Vn to the 12 by Vref. Now I'm converting that code back to voltage by multiplying by Vref of 3.3 and then divided by 2 to the 12, which is 4096. And here's my waveform chart, okay, which is this on the front panel. So once I have the waveform, I can click on the run button, and right now I'm gonna vary the RPOT. Let's see, it's about 1.5 volt. I can go up to 2 volts, 2.1, 2.4, go to maximum 3.3. I can go down, step down a little bit, 1.7. It's a little bit noisy, but you can see how I'm varying between 1 volt to 3.3. So that's it. That's my demo of how to read in a voltage using the internal ADC 12-bit inside an MSP430, and then sending that serially through UART and using Labview to capture that code in terms of voltage versus time. Thank you for watching.